Title of today's webinar is Extend the Power of Your Spreadsheets. I'm Dennis Buckmaster, a professor in Ag and Biological Engineering and also a Dean's Fellow for Digital Agriculture. This is part of a fuller series related to the digging into the data pipeline, and in particular, sort of a subset of that series related to the use of spreadsheets, Excel and Google Sheets. Today, we're going to build on a previous webinar that was titled Create Savvy Spreadsheets That Work Better for You by adding some other features from Excel, namely forms, data validation, a thing that's called data table, which is very different in Excel than just a table of data. It is a specific tool. We'll uncover formula auditing and then introduce protection so that you can keep your spreadsheets from getting messed up accidentally. And at the end, we'll also introduce a new workbook. It's an Excel workbook that we're calling the Purdue Crop Planning tool. So just a little bit of a refresher. In English, we read from left to right. We read from top to bottom, so let's compute in that way. So you're going to see a spreadsheet that has all the inputs gathered at the top. The calculations will flow very straightforwardly, top to bottom. There won't be any spaghetti flow of jumping here and there to find things and compute things. We will fight the urge to hide things. Everything will be explicit and clear in the calculations. And as you'd guess, the bottom line is at the bottom. So since we refer to things as names, we're going to use names also in the spreadsheet. So instead of calling out cell references, we'll call them variable names so that when we're reading our spreadsheet, it reads like the math that you would see in textbooks or other publications. So let's just do it. We're going to start with that open road of a blank spreadsheet. And this is the problem that we're going to solve today. I know you could read it, but I want to read it out loud to provide a little bit of emphasis. This is a problem that actually comes from one of my old books. I have an old book hobby. I love collecting old books that relate to engineering and agriculture. And this is one of the problems out of one of those old books. A farmer wants to buy an extra 40-acre field and has two fields of the same quality of land offered to him. So identical fields, different location. Classic real estate problem. What matters is location, location, location. One of those fields is 16 rods from his farmstead. The other, 160 rods. How much more could this farmer afford to pay for the nearer field if he must take an average of 30 round trips to the field during the year? And when he makes a trip, it's a round trip with 3 horses. He travels 6 rods per minute, and the rate of labor, the cost of labor is 20 cents per hour. The cost of horse labor is 12 cents per hour. The cost of machinery labor is listed at 6 cents per hour. And then money is at 6%. There's the problem. Let's go solve it in Excel. I'm just thinking that my great-grandmother, Charlotte Buckmaster, if she had only had Excel, she could have helped her husband, my great-grandfather Eli, solve this problem quickly, and then he could get back out into the field rather than staying inside and spinning his pencil. There's the problem. We've already read it. Just to save time, it's pretty tedious and boring to watch somebody type some things into a spreadsheet. So just to save time, I've already set up this tool in this way, with the inputs all gathered at the top, intermediate calculations to follow, and then in the end, our final calculations will be below. And we'll get to this one in a little bit, the code for a number of years, because I'm going to actually use a form. But let's start with just revisiting the problem, entering in information over here. So the land being considered was 40 acres. The distance is 16 rods. That's one way. The number of trips is 30 per year. The number of horses, there were 3. Travel speed is 6 rods per minute. Land labor rate, horse labor rate on equipment or machinery labor rate there, and then also the interest rate. So that just sets up the problem. And what I want to do is insert a form here for the number of years. Actually, that's not stated in the problem statement, but it will become more evident in the end. So let's just start there. We need the developer tab, and I have the developer tab in my Excel. You might not. If you do not, to get it, you go to the file, options, File, Options. We're going to go down here and customize the ribbon. File, Options, Customize the ribbon. And there it is here in the ribbon developer tab. If it is not checked, you would check it. And that's like raising your hand and saying, I'm an expert, let me have that thing. And so I will check it and get okay. And that's how you get the developer tab to show up. Once you have the developer tab, I'm not going to explain the whole thing. This is a demonstration. I'll just show you how to use it. We're going to insert, and we're going to use form controls. There are these things called ActiveX. Stay away from those unless you want to write sort of hardcore computer code. So stick with the forms. If I hover, you'll see that there are options for a button, a combo box, a checkbox, a spinner, etc. So let's just do this combo box. And what I'm going to do then is simply draw a box. I'm probably not drawing it the right shape or anything, but I'm just putting one. There is the form. That was easy to add, but actually the form doesn't do anything. So I have a motto that I have my students learn, and it's, when in doubt, right click. So go ahead and say that out loud wherever you are. When in doubt, right click. If you want to do something, but you're not sure exactly how to do it, very often the solution is in the right click. So I'm going to right click on that form that I just added. I can do these things. What I really want to do is control it. So that's the format control. There are lots of things here about size, protection, properties, alternative text. What I want is control. And what I need to tell it is, where is the input range? What should show up in the form? Well, just so happens that I had hidden to you, but over here on the side, I have a year options table. And so I want to consider 1, 5, 10, up to 30 years. Of course, that could have been just a cell entry. The user just types in a number. But so that I can illustrate a form to you, I have that as a set of numbers that I want to show up in the form. The magic is this. I need to give it a cell link. That is, when someone uses the form, where does the result go? Well, looking at my layout here, I've called this thing a code for the number of years. It's the output from the form. So actually I'm going to hide it behind the form. And I want the result of the form selection to go into the cell C2. And click OK. Now, just to show that it's actually working, I'm going to right click so that I can move this to the side, just for now, so that you'll see if I choose that form, I can choose 1 or 15 or 30. Does it strike you odd that when you choose 5, you don't get 5, you get 2? What's that about? Well, what a form does is it just returns out of the options which number did the user choose. So if I choose 10, the form actually returns 3, which means you chose the third option, which is why over here I have the code. This essentially is the code, and this is the number of years. So we'll put that to use shortly. Well, let's go do it now. If a user chose the second one, they chose 5, you get the second one. What I need to do down here is now get the number of years. So I want to interpret this thing called 2 and make it actually be a 5. Well, that is the VLOOKUP function. So before I do that, though, I want to use the variable names. And this was covered in the earlier webinar. So I'm going to go to Formulas and actually highlight all these rows that have some names in them. I'm even going to do a few more because you don't see them, but they are there. I go to Formulas, Create from Selection, and I'm going to use the left column to define the names. And when I do that, I'm really saying, when I choose any column in row 3, refer to it as A, area. In row 4, I can refer to it as D, distance, rather than calling it C4, since C4 is an explosive and I don't want my spreadsheets to blow up. Once I've done that, now I can go to the VLOOKUP function. Remind you of the function wizard. Here, it is your friend. It helps you through the syntax of things. So let's use the VLOOKUP function. I'm going to look up. It's the value to be found. Well, I'm looking for this thing called CNY, which at the moment is 2 because the user chose the second thing. I'm going to look for 2. Where am I going to look for 2? I'm going to look over here in this year options table from P2 to Q7. I probably should have given that a name. It would be a little nicer, but this will suffice. The column index number is the column to return. Well, I only have 2 columns, 1 and 2 in this table. When I find a 2, what I want to return is what is in the second column beside it. In this case, the range lookup, it can either skip it or put true, but I am looking for an exact match. But I don't really have to worry about that because I'm forcing the user to use a form, so they can't put in something that doesn't make sense in that spot. So there we go. I've got a spell error. What is that about? That's because I'm doing this on my computer at home, which has the newest version of Microsoft Excel. And so anytime I use a named variable, I must have the little @ sign in front of it. It's kind of a hiccupy sort of a thing. If you have a 2010 version of Excel or older, you don't need that @ sign. But anyway, that solves the problem. And then, just like we did a couple weeks ago, I'm going to copy that, paste it over here in this other column, change it from a formula that starts with an equal sign to something that starts with a single quote, so that you can actually see what's going on in that cell, but over here. All right, so there is the whole problem. Now let's solve the crazy thing. There illustrated a form. Let me do one more illustration, and that is use data validation. First of the list type. Data validation forces a user to put in a valid entry into any input cell. So I'm not going to use data validation on all of these. This webinar would be too long, but let's just choose a couple. So let's first do on the number of horses. If you notice over here, you didn't see it, maybe you noticed. I have a little num horses for data validation list here. Like consider 1, 2, 3, or 4 horses. I guess if I wanted to make it bigger equipment, I could go up to 6 horses, but I don't really know the horse to acres ratio, whether that makes sense or not. So let's go to the number of horses. Instead of just typing in a number of horses where a person could put in 120.5, well, that would be nonsense. You can't have a half a horse, and that's way too many horses. I can force the user to put in a valid, decent number in data validation. So that's data validation. And in this case, I'm going to use not any value, not whole numbers, these are options, but I'm going to force it from a list. And the source of that list is this range of cells over here. And I should, if I have data validation, I should always have an input message. Choose. It's the number of horses for each trip. There should be an error alert, like if you choose something incorrectly. Be polite here. In some message to the user. Now, if you put your cursor, anyone puts their cursor on that cell, they get the clue from the data validation. Choose the number of horses average for each trip, and I have a choice here. And so I'll choose 3. Now, that's different, slightly different than entering in a number. Let's do another data validation of a different type. Let's do a range. And so let's go to travel speed. And let's do a different data validation on that one, just for illustration. So I'm going to go to the settings. I want it to be, let's see, probably we would only know speed to the nearest whole number. Like we would, maybe, I suppose you could have half a rod a minute. So let's go ahead and include that. It's decimal. It's going to be between, well, if a reasonable value is 6, then let's have really slow horses. Maybe they go 3, and really fast horses go 10 rods per minute. Oops, I didn't do what I meant to do. Go back to that data validation. And let's add the input message. Average speed of getting to and from the field. The error alert. Oops. You entered an incorrect value, try again. Now, let's also go back to here. If I'm giving the user a guide, enter an average speed to and from the field, if I've already programmed that the valid values are from 3 to 10, I should include that in my input message. So they're from 3 to 10 rods per minute. Okay, so now I see that message when I'm there. If I try to enter 22, I get an error. Oops, you entered an incorrect value. Try again. So I'll retry with 6. So that's data validation of 2 types. Now let's go ahead and solve the whole problem. How many man hours would I spend doing all of this? Well, I think it would, I'm just going to kind of build up the formula as I'm thinking about it. Start with an equal sign. Let's see. If I need to go a distance of 16 rods, that's D. I actually need to go D 2 times. I have to go there and back. So that's D times 2. How long would it take to go there? Well, if I take distance, which is rods, and divide by rods per minute, I'll get minutes. So I need to divide by this travel speed. You know what? I just remembered I might as well put those @ signs there, or I'm going to get the still error. So if I stop there, I'll put brackets around that. If I stop there, what do I have? I have minutes, not hours. So I should divide by 60 to get hours. Now that's how long it would take for each trip, correct? Yes. And so how many trips do I have? NT. So I need to multiply that times the number of trips. Let's see if this makes sense. 2.7 hours. And let me paste this over here, change it from text, or from a formula to text. So I've taken the distance divided by the speed, convert the units to hours. That was, the first part of that was per trip, and I have a certain number of trips per year, so that's hours per year in man hours. So how many horse hours do I have? Well, I think it's going to be man hours times the number of horses. For every man hour going, there are 3 horses at the same time. All right. Oops, I didn't like what I did there. I didn't have the @ sign. How about man labor cost? Well, if I have so many man hours, at the moment it's 2.7, and I have a man labor rate of cents per hour, that will give me cents per year, correct? Hours per year times cents per hour is cents per year. So if I want it in dollars, I'll divide by 100, and then I better fix my parentheses. How about horse labor cost? Well, that's going to be at the horse hours times the horse labor rate, also divided by 100 to get dollars per year. And how about the machinery cost? Well, the machinery hours in transport, this is only considering getting to the field, not the work in the field. The machinery time is going to be essentially the same as the man time. So I'll just take the man hours times, but in this case, it's the equipment labor rate. It's kind of an odd sort of a term there, but an equipment rate in cents per hour, and then divide by 100. And so if I sum those 3, the man cost plus horse cost plus equipment cost, I'm going to get dollars per year to get this transport done. And then if I want the total cost over the years, well, now we've got to sort of think in a different realm. But before I do that, let's get all of these showing. Copy those, paste them over here. Do you remember the shortcut is Control H? While I'm highlighting in column E, I can Control H, replace every equal sign with a single quote and an equal sign. Replace it all, and I see then my formulas. All right. Now, in the case where I only want to consider 1 year, then that is the cost for this year. But maybe I would consider a 5-year lease on the land, or maybe I would buy it with a 20-year loan. And this is where interest rate comes into play. So I need to take that amount per year, essentially, and convert it into what's the total cost over a number of years. And this isn't a time value of money lesson, but we need to apply it here. So I'm going to use the function wizard, and it's the present value function, where the rate is I must divide by 100 because up in row 11 it was indicated as a percent. This needs to be a decimal. The number of periods is the number of years. And oops, let's do the @ sign in there. Forgot to do that. The payment is that cost sum. which at the moment is $1.65 per year. FV, we can skip. And then the type, well, if you're going to pay for land, usually you'd pay for that up front. So I'm just going to put in a 1 at the beginning of the period. So we'll get in the case of 1. Now it's a negative sign. I'm actually going to change the sign on that just by putting a negative sign in front of it, because I'm thinking of it as a cost. And so it's $1.65 a year. So just to show the value changes, let's change this to be, and instead of doing it just 1 year, I'm going to buy the land. And I want to amortize all of that travel over the road over 30 years. That's like $165 this year and next year and next year and next year. That is equivalent to $24 all at once here in the first year. Let's get that formula showing over here also so you can see it. All right, now remember in the problem, we really wanted to compare a near field and a far field. This is where the magic happens. Right-click on column C, which is really only one field. And then right-click on D, insert the copied cells. Let's label this first one the near field, the second one the far field. What's different is the distance to the field. Now, I looked ahead and I realized that when I used the form over here for the number of years, it was only reporting, if you remember, to C2. And so I'm going to pull a little trick here and make the number of years in the far field simply be the same as the number of years in the near field. Like I'm going to compare apples to apples here. And so in this case, then this formula, which is looking up this, it does have an error. And the reason is here, the range that it looked up was Q2 to R7. When I copied that formula, because they were relative references, I need to fix it. Shame on me. I should have used a name and called it the years table or something like that. And then actually I now see here that it even documented it incorrectly. So let's tidy that up. Now you'll see I have a side-by-side comparison, the near field and the far field. I have a couple things down here that I already typed in, but I just made the font so that you couldn't see it. So now let me uncover it so you don't have to see me typing in so much. Here is the total for the near field and the far field. So what I want to know is, what is the annual cost difference? Well, that is just going to be, and I'm going to use cell references because the names don't work so well from one column to the other. So I'm going to take the far minus the near field, and the annual difference is $14.88. The total justifiable payment difference over those number of years is the far minus the near. That's the number of dollars for the farm over, in the moment, it looks like 30 years. The justifiable price difference then per acre is that divided by the area of the farm. So it comes out to be $5.43. But you could justify paying more for the near farm than the far farm. That doesn't seem like much. So I am going to show you from my internet search, these were the costs of land back in the day. They were on the order of, look at these years, 20 to 25, maybe in a particular year more, but low 20s dollars per acre. So that difference of $5 out of 20 something was pretty significant. I now want to illustrate this thing called an Excel data table. It's under data. In the what if analysis, it's called a data table. But before we do it, we actually have to set it up a little bit. And now looking back on how I did this with the form for the number of years, it's going to be a little clunky, but I think you'll get it. I have different options for that code for number of years, which is 1, 2, 3, 4, 5, and 6. And for any one of those choices up there, I would get different output down here. And I could do them one at a time, but the advantage of a data table is to look at multiple scenarios all at once. And so these 3 cells here of this one-dimensional data table are the setup cells. So I'm going to color them. And what this means is we must point to, where does the answer come from? And so when the code for years is a number, where does the number of years come from? It is here in C13. Where does the difference in today's dollars come from? It comes from C23. And the difference on a per acre basis comes from C24. Once I've done that, then I can highlight all of that range, realizing that this is just a label, doesn't matter. But I will go to Data, What If Analysis, and a data table. In this instance, we do not have a row of inputs. We have a column of inputs, which is either a 1, 2, 3, 4, 5, or a 6. Where should effectively that 1, 2, 3, 4, 5, or 6 go? It would go up here in C2. Then we get magic. I get all of the possibilities of from year 1, 5, 10, 15, 20, and 30. These were the total difference in dollars today. And then this is on a per acre basis. That's the power of a data table, to run a single scenario over and over. You can also have two-dimensional data tables that vary two things. So we could vary, for example, the number of years and the distance difference between the two fields, or the size of the two fields, or the interest rate might be a very interesting one. The last thing I will just illustrate here is protection, and that's under the home ribbon. No, it's not. It's under review. Here's the protect sheet. In this case, if I had this perfectly set up for my great-grandmother, Charlotte, then probably what I would want to do is highlight this part, and those are the only cells that I would want her to change. So then I would go to the home ribbon and bring down the whole of the formatting and go to protection and essentially unlock, because by default, everything would be locked. I will unlock those cells. Protection is a two-step process. First, identify which cells should be changeable, which ones should not be. Once I've done that, then I can go to the Review tab, protect the sheet. I'll do it without a password, because if I give it a password and I forget it, I am out of luck, because nobody in the planet would know the password. So I generally protect without a password. Okay, and now at this point, if you try to change anything anywhere other than the input area, you'll get an error. But if you can change things in the input area, including the form, because the form is driving this particular cell, which also spills over to that one. There's a demonstration of all of these things: forms, data validation, data table, formula. Oh, we did not do formula auditing. To do that, I need to unprotect the sheet. And just as an example, I could put my cursor here and try to find under the formula ribbon, trace the precedence. What are the cells that feed this one in terms of formulas? And I see that it's straight up the chain. This one, if I taste the precedence, it's a function of these two. And you'll find that for the most part, if you do your spreadsheets in this way, the auditing is kind of boring, because it's always sort of straight down. I would like to take just a couple minutes to introduce a new workbook that we're making available. Actually, this one comes with its own orientation video that's about 15 or 20 minutes long. But just briefly, I'll just show that. Imagine a workbook, and you don't have to imagine it. You can go get it. Where first you would describe your fields, give them a label, and identify their area. Then you would also list for your farm, what are the seeds that you're considering this year? What are the fertilizer combinations that you might use on your fields this year? What herbicides, including their rates and prices, etc. If those sorts of tables were populated, including insecticides and fungicides, then you could, by field, identify some yield goals and other income, and then for each field, specify which fertilizer are you using, which includes a rate and the price. You would select the seed. So you have all of your crop inputs listed. You would have other costs, including cover crops and water management, the machinery costs to doing things on the field. You're doing this essentially by field or by management zone within a field. And from those things, then in the same style of format that we were just looking at, with named cells and easy to read formulas, we would compute all of the costs, generate the income by field, and then also sum over the entire farm for all of the fields that you have. And as shown here, only 3 fields, but you can add more fields, you can delete fields. Then, in addition to that, a sensitivity table that shows you, well, what if yield's a little less, a little more? What if prices are a little lower? What if they're a little higher?
And then in this side-by-side scenario, then you can very quickly compare a projection. It's not a prediction, but it's a projection of how would this field come out if I managed it in this way. If I put these products on and had that yield compared to these other products and projected a different yield. So easy to do side-by-side comparisons as well as a summation over the farm. And then the other key thing is then you get a tally of what are my seed needs, my herbicides and fertilizer needs would be automatically tallied. So again, there is a separate video on that one. There is a post here about that we can share. And then this tool is completely free. It is protected to keep you from making accidental changes, but for those of you suitably inclined and trained in Excel, feel free to customize it to your best ability.
So with that demonstration of some of the Excel features and a little exposure to the Purdue Crop Planning tool, let's take time for some Q&A. Maybe you'd like me to demonstrate some things again. That's certainly fine, but please use chat or unmute and let's have some good discussion.